Hello my lovely viewers, welcome again to Mathematics and I. It is a presenter Jefferson, and today on the board we have 3 questions that we shall be looking at. Now all of these 3 questions are on trigonometry, and we shall be seeing how we can apply various formulas and various techniques in solving these 3 questions. Okay, question number 1 says, given that tan x equal to 1, where 0 degree less than equal to x less than equal to 90 degree, evaluate 1 minus sin square x over cos x. And then number 2 says evaluate sine 15 degree. And lastly, question number 3 says, given that x equal to cos 30 degree and y equal to sine 30 degree, evaluate x squared plus y squared over y squared minus x squared. Okay, without wasting time, let us begin the class. Don't forget, if this is the first time of joining us, don't forget to subscribe to our YouTube channel, Jeff Nino, and also don't forget to follow us on Facebook, Mathematics Booster. Okay, let us begin with question number 1. Question 1 says, given that tan x equal to 1, tan x equal to 1. Now, without wasting time, if tan x is 1, it means x is equal to 45 degree, because it is only tan 45 degree that will give us 1. So it means x is 45. Okay, let's proceed. Now we have 0 degrees less than equal to x less than equal to 90 degree. It means our answer is between the first quadrants. Okay. Evaluate 1 minus sin squared x over cos x. Okay, before I'll proceed in solving this math, evaluate 1 minus sin squared x over cos x. Okay, now from trigonometry ratios, we have a formula which says sine square x plus cos square x is equal to 1. So, if sine square x plus cos square x is 1, if I should make cos square x the subject of the formula, we're going to have this cos square x is equal to 1 minus sine square x. Because for cos square x to be the subject of the formula, sine square x has to go to the right hand side. So when it crosses, it becomes minus sine square x. So what does that mean? In the question, we're told to evaluate 1 minus sine square x. And we just saw now that 1 minus sine square x is the same thing as cos square x. So what are we going to do? We're going to substitute for 1 minus sine square x, cos square x. Okay, rewriting this, we're going to have cos square x over cos x. Okay, all right. Now, when you say cos square x, it simply means cos x into 2 places. So, if I have cos x into 2 places and I have cos x down, it means if cos x should cancel cos square x, I'm going to have just cos x. Okay, now don't forget we said x is 45 degree. So, automatically, wherever I see x, I'll write cos 45 degree. And cos 45 degree is the same thing as 1 over root 2. Then if we should rationalize this, cos 45 degree becomes root 2 over 2. Okay, so this is the answer to question number 1, which says evaluate 1 minus sin squared x over cos x, given that tan x equal to 1. Alright, now without wasting time, let us go to question number 2. Now, question number 2 says evaluate sine 15. Okay, evaluate sine 15. Okay, we have to clean this so we have a lot of space to work on this. Okay, evaluate sine 15 degrees. Question 2, evaluate sine 15 degrees. Okay, now if you are to evaluate sine 15 degrees, how do you go about this? First of all, 15 degrees is not a special angle. This is not a special angle, and there is no way we can evaluate this if we are not using our 4-figure table or if we are not using our mathematical sets. But in this question, we're not supposed to use mathematical set, we're just supposed to evaluate sine 15. So how do we go about this? Now, this is what we're going to do first. Now, think of 2 numbers that either you add or you subtract, and then you get 15 degrees. Now, I think the first two, we can use the numbers 60 minus 45. Okay, now 60 minus 45 gives us 15, and also 60 and 45 are special angles. So this is exactly what I'm going to be using in solving this question. So it means sine 15 degrees is the same thing as sine 60 degrees minus 45 degrees. This is exactly what I'm going to be using to solve this question. Okay, now before I proceed with this, there's a part in trigonometry known as compound angles. And compound angles are used when you are solving, sum and difference of angles, when the angles are the same or when the angles are different. For instance, the angles here are different. This is 60 degree and this is 45 degree. So we have a formula for this. So I'll be giving you the formula for solving sine when you are subtracting when the angles are different. Now the formula is this. Let us use A minus B as the angles, meaning here A is 60 and B is 45. Now sine A minus B gives us sine A cos B minus cos A sine B. Yes, this is the formula we shall be applying in solving this question. Okay, sine A cos B minus cos A sine B. Alright, now if for instance we have plus, if it was plus, it should now be sine A cos B plus cos A sine B when using the compound angle formula. Now let's substitute. A is 60, B is 45. So I'm going to be having sine 60 degree minus 45 degree equal to sine. Now A is 60 degrees, okay, cos. Now B is 45 degrees minus, A is 60 degrees cos 60 degrees. This B is 45 degrees sine 45 degrees. Okay, let us proceed. Sine 60 degrees is the same thing as root 3 over 2. Okay, special angles. Into the bracket of cos 45 degrees. Cos 45 degrees is root 2 over 2. Okay, if we rationalize it. Minus cos 60 degrees is the same thing as sine 30 degrees, which is 1 over 2. Okay, into the bracket of sine 45 degrees is the same thing as cos 45 degrees, which is root 2 over 2. Okay, alright, let us open the bracket. We're going to be having this. Root 3 times root 2 gives us root 6, 2 times 2 gives us 4, minus 1 times root 2 gives us root 2 over 2 times 2 gives us 4. Okay, now if you take a look at this, we're going to be looking for the LCM of 4 and 4, which we know is already 4. Alright, now the LCM is 4. Now, how many times will 4 go into 4? Is 1 times. 1 times root 6 gives us root 6. Minus 4 also into 4 gives us 1. 1 times root 2 gives us root 2. Now, because the numbers in the roots are different, there is no way we can subtract. So root 6 minus root 2 over 4 becomes the answer if we should evaluate sine 15 degrees. Now you see how we go about this even without the use of our calculators. Just because we're able to change 15 degrees to become special angles using 60 minus 45 degrees. Okay, apart from 60 minus 45 degrees, we can also use, 45 degrees minus 30 degrees. Yes. 45 degrees minus 30 degrees will still give us 15 degrees because 45 and 30, they are also special angles. And if you should work that at home in your leisure time, you see we're still going to get the same answer, which is root 6 minus root 2 over 4. Okay, alright, now we're going to question number 3, which is the last question for today. And the question says, let's see, question number 3. Okay, question number 3. Now, question number 3 says, given that x equal to cos 30 degrees and y equal to sine 30 degrees also. Now we were told to evaluate x squared plus y squared over y squared minus x squared. Okay. Without wasting time, we already know what to do. We were given the value of, we were given the angle for x cos 30, also y sine 30. So what we are going to do is that we are going to substitute this cos 30 and sine 30 for x and y in what we are told to evaluate. Alright, now x now is cos 30, so here becomes cos square 30 degrees, okay, plus, now y is sin 30, so I have sine square 30 degrees over also y is sin 30, sine square 30 degrees minus cos square 30 degrees. Okay, all right, now we have been able to substitute for xy in the equation. In the question, sorry. Now, what is the next thing we're going to know? What is cos 30 and what is sin 30? Okay, now cos 30 is the same thing as sin 60, which is root 3 over 2. So, anywhere I see cos 30, I'll give root 3 over 2. So, here it becomes, but don't forget that cos 30 is carrying the square. So, it becomes root 3 over 2 all raised to the power of 2 because of the square, plus, now sin 30 is 1 over 2, which is the same thing as cos 60. Okay, so here it becomes 1 over 2 also raised to the power of 2. All over, and sin 30 again becomes 1 over 2 raised to the power of 2 minus root 3 over 2 raised to the power of 2 also. Okay, now you can see this is simply a fraction. Fraction indices put together. So the first thing I'm going to do is that I will what? Eliminate these roots, this square. Now how can I remove this square? By squaring everything inside the bracket, because the square affects everything inside the bracket. So when I do this, I'm going to be having something like this. Okay, root 3 raised to the power of 2 over 2 raised to the power of 2 plus 1 raised to the power of 2 over 2 raised to the power of 2 all over 1 raised to the power of 2 over 2 raised to the power of 2 minus root 3 raised to the power of 2 over 2 raised to the power of 2. Yes, the square affects everything which is the base inside the bracket. Now that is what? Now, square root 3 raised to the power of 2 simply means root 3 times root 3, which is the same thing as root 9, because 3 times 3 gives us 9. And then the square root of 9 is 3. So it means root 3 raised to the power 2 gives us what? 3. Or in short form, when you say root 3 raised to the power 2, just say square roots cancel out square. And what do I have there? 3. So here becomes 3 over 2 raised to the power 2 is 4, plus 1 raised to the power 2 is 1, which is 1 times 1, and 3 raised to the power 2 also is 4. Okay, all over, now yes, it becomes 1 over 4 minus 3 over 4. Okay, alright, without wasting time, let us proceed. We have two fractions here, one at the numerator and one at the denominator, and we're going to solve, with their LCM. Now we all know that the denominators here are the same. Okay, mind you, when the denominators are the same, there is no need for you to find the LCM, because the LCM will still give us the denominator. So because the denominators are the same here, I will just simply do 3 plus 1. It will be possible. But if they are different, it can never be possible to do 3 plus 1. I have to look for the LCM first. So if the denominators are the same, 3 plus 1 gives us what? 4. So here becomes 4 over 4, which is the denominator. Okay, all over. Now, also the denominators here are the same. So I can just say 1 minus 3. Now 1 minus 3 gives us minus 2 over the denominator, which is 4. Okay, now 4 divided by 4 gives us 1. So here becomes 1. Now instead of me writing all over, okay, I simply write divided by, because all over is same as divided by. Now, I believe minus 2 can cancel 4. Now, I believe 2 can cancel minus 2 and 4. Now, if 2 should cancel minus 2, I'll be having minus 1. And if 2 should cancel 4, I'll be having 2. Okay, now without wasting time, we have division separating these two fractions. Now, when division separates two fractions, division becomes multiplication. And when division becomes multiplication, the fractions immediately after the division sign reciprocates. It goes upside down. So if division here becomes times, it means 2 goes up and 1 comes down. So here automatically becomes 1 times minus 2. There is no need for me to put over 1, because minus 2 over 1 will still give me what? Minus 2. So automatically 1 times minus 2 gives us minus 2 as our final answer. So this is the answer we're going to get if we should simplify x squared over y squared minus x squared, given that x is cos 30 degrees and y is sin 30 degrees. So class, we have come to the end of today's section, and I hope you have learned something new. If this is the first time of joining us, please don't forget to subscribe to our YouTube channel to see more of our videos on Jeff Nino, and just go to your YouTube and search Jeff Nino, and then you see our videos there. Please don't forget to subscribe, and also don't forget to comment and share our videos. And also you can follow us on Facebook, just write Mathematics Booster, and then you see our page, and then please like and follow. So to meet again about the next class, keep on watching Mathematics and I. God bless you.